Hello there, IM3 students. This is your solution video to the Unit 1 quiz. So, one thing I want to point out is that pretty much every single kid was able to get parts A and part B of this thing. If you could do part A and part B of number 1, part C is really easy. And also, if you can do all of number 1, number 2 should be a snap. So, that said, here we go. We had Flacco the Flamingo, and he's been putting on weight steadily since the day he was born. It tells us 6 days after he was born, he weighed 26 ounces. And it also tells us 10 days after he was born, he was up to 38 ounces. And it also says he's been putting weight on steadily. Okay, so we have a steady rate of growth. Well, pretty much everyone said, gosh, it looks like he went from 26 ounces to 38 ounces. And a lot of people took that difference, 38 minus 26. And they said that's 12. So he's put on 12 ounces. And it's been from 10 days to 6 days. From 10 days to 6 days is 4 days. And so if we wanted to find out his rate of weight gain, it would be 12 ounces in 4 days, so that is 3 ounces per day. Okay, some people, in order to figure out how much he weighed when he was born, some people wanted to make an XY table. That's okay. Make a table here. We know that at day 6, he weighed 26 ounces. And if it's 3 ounces per day, we could just count back the days. 5, 4, 3, 2, 1, 0. Day 0 would be the day he was born. So we could just count back. Let's see, day 5 would be 23 ounces. Day 4 would be 20 ounces. Day 3, going back 3 again, would be 17 ounces. Day 2 would be 14 ounces. Day 1 would be 11 ounces. And day 0 would be 8 ounces. So that's one way to arrive at this answer, 8 ounces. Another way to arrive at the answer is this. If we know that his weight is steady, then what we know is that we have a straight line growth. Incidentally, I have a little Desmos thing going on here. Sure enough, at 6 days, he weighed 26 ounces. So at 6, we're at 26. And at 10 days, we're at 38 ounces. When we found this rate of 3 ounces per day, we found this rate of 3 ounces per day, we were finding the slope between these 2 points. If you even remember your slope equation, that's y2 minus y1 over x2, yikes, x2 minus x1. This is exactly what we did intuitively, just because we understood the situation. So we know the slope between these 2 points is 3. So what we could have done is we could have said, well, I know my equation must be y equals 3x plus, I don't know a start value. I'm going to pretend I don't know this a. So I could say plus b. And in order to find this b value, this y-intercept, we could have used any point, any xy point that we know. And, well, here's an xy point, 10, 38. We know that after 10 days, he weighed 38 ounces. So there's an x, there's a y. I could have said 38, and for y equals 3 times 10, plus some mystery start value. That's 30. Plus b. And then I could have subtracted 30 from each side. And again, we get that b equals 8. So there were 2 ways that you could have found that start value. Now that we know a start value, and we also know a slope, we can write the equation of that line, answer part C. The equation of this line is y equals 3 ounces per day plus the 8 ounces that he started with. That said, you didn't need to do any work for part B. You could have done all the work again, but these values are exactly the same. 626, that's 6 days. He weighed 26 ounces. And after 10 days, he weighed 38 ounces. So we could have just written the equation online. Y equals 3x plus 8. Just for kicks, I'm going to go to Desmos and check it. Let's see. We graph that line. Sure enough, that line goes right through those points. And there are no other lines that are going to cross both of these points. And we could go down here and see, yep, it's got a y-intercept of 8. If you did decide to go ahead and do all the work again, and most people decided to go do all the work again, you could go back and say, all right, it's the difference of the y's, which I always call it the change. That little delta means change, so change in y's. So it's 38, oops, what did I just do there? 38 minus 26. So I went from this y to that y over the change in x's. Change in x's. And my x's would go from 10 to 6. But you'll notice you've already done this. You already did it. Now, up there at part A, you already did it. So, in any event, you still get 12 divided by 4. You still get a slope of 3. And you can do exactly this procedure all over again to get that y-intercept. But the short way to do this is to recognize that you already have the answer. Let's take a look at the next problem. Next question was about Heloise the hippopotamus. So let's see, she's been on a weight plan, and it says every week her weight changes by exactly the same number of pounds. So the situation is modeled by this equation. I was looking for a couple of things when I graded part A and B of this thing, mostly part A. In part A, it said describe her weight plan. Is she losing or gaining weight? So I was looking for you to say that she is losing weight, and we know that she's losing weight because it's negative. So she is losing weight. And I was also looking for you to answer the question, how quickly? If it's -2, she's losing 2 pounds per week. Losing 2 pounds per week. And the what else do you know? You can know one other thing. This value here, what do you think that 350 means? Well, it's a y-intercept. It's also called a start value. So we know that she started at 350 pounds. 350 pounds. And that would get you all 3 points. I made this problem here worth 3 points. Part B says, after how many weeks would she weigh 318 pounds? There are multiple ways to do this correctly. The way I would do it is I'd use the equation. I know that her equation is y equals -2x plus 350. I know that this -2 is her rate. X tells us how many weeks it's been. And the 350 is a start value. Y would tell us her ending weight. Ending weight. So if you wanted to do this using an equation, you could say, well, we know her ending weight needs to be 318 pounds. So I would scratch out that y and put in 318. And we could just solve an equation. 318 equals -2x plus 350. We can subtract 350 from each side, minus 350. I really don't like borrowing and doing subtraction problems like this, so I would think of counting up. I know I'm going to have a negative number over here because -350 is bigger. So to get from 18 to 20, that's 2. So I know I have 2. And to get from 20 to 50, I'm going to have 30. So it must be 32. equals negative 2x. And if I divide both sides by negative 2, negative divided by negative makes my answer positive. It turns out it is 16. So it is after 16 weeks. After 16 weeks. Now, there are other ways that you could have done this problem. You could have made a table and just counted back. And I can see that some people did that. They said, okay, well, we know at 0 weeks she's 350. So we could skip ahead maybe to 10 weeks. 10 weeks she's lost 2 pounds a week. So after 10 weeks she's lost 20 pounds. So she's down to 330. We could go another 5 weeks. After 5 weeks at 2 pounds a week, she'd lose another 10 pounds, so she'd get 320. And so if we go one more week should be 318. So it's then 10, 5, and 1, so 16 weeks. That's another way to do it. I didn't really make a table there. Or you could have made a table. It would take a long time, but you could say, all right, make this an XY table. XY, after 0 weeks, we're at 350. After 1 week, we're at 348. This would take forever. After 2 weeks, we're at 346. I think you get the idea. And we could just keep doing that until we get down to 318. And that would take 16 weeks. Let's move on to number next. Number 4. Number 4, factor this expression. This should be review material from right toward the end of last year. And so a couple of ways to do this problem. Some teachers say, well, you're looking for a couple of numbers that multiply to 8. Not much. Multiply. You're looking for a couple of numbers that multiply to 8 and add to negative 6. So that's one way to think about it. Another way is you can just make some parentheses and hope for the best. Let's see. I know that this x squared had to come from x times x. I know that numbers that multiply to 8, well, if I tried 8 and 1, and when I multiply this thing out, I get 8x here and 1x here. And 8 and 1, there's no way that's going to combine to 6. So I'm going to forget about 8 and 1 and try, I don't forget about these, I'll try other numbers that multiply to 8. How about 4 and 2? 4 times 2 is 8. If I multiply x by 4x, I get x by 4, by the way, I get 4x and 2x. So for these to combine to negative 6, they would both have to be negative, negative, and negative. So that's one way to do this problem. I've seen some of you drawing rectangles. I think that's a great way to do this problem. To say, okay, well, I know that we have x squared, and that had to come from x by x. Numbers multiply to 8, and you again have to figure out what numbers multiply to 8. 4 and 2 are going to work, we know. So we have x times 4 is 4x, x times 2 is 2x. So if we had 2 negatives and 4 negatives, then we know that x minus 4 times x minus 2, x minus 4 times x minus 2 will work. So either way you slice it, you get the same answer. Let's take a look at the next one. Solve some equations. Okay, again, these should be review questions. Number A. Number A, we would want to do the distributive property first. So I want to multiply 2 times x and get 2x. We want to multiply 2 times negative 5 and get negative 10. We bring down everything else. There's a plus sign there and a 3x, an equal sign, and negative x, and a plus 7. I think a smart thing to do before we do any moving around is to combine like terms. Combine the 3x and the 2x to 5x minus 10 equals negative x plus 7. And then to solve for x, I'll eliminate this negative x with a positive x, but I'll have to put a positive x on the other side. So I get 6x's minus 10 must equal positive 7. And then I'll get rid of this negative 10 by putting a positive 10 on each side of my equal sign. I get 6x's equals 17. And I did warn you all that this one, you would have some answers that just don't work out nicely, and this is one of them. If you divide by 6, 17 does not divide by 6, so I would just leave the answer as 17/6. Yay! For the next problem, this guy, there were a lot of troubles with this. Let me see if I can make some room for myself. All right, for question B, we had a lot of issues here. And again, I'm going to show you two ways to go about doing this. One way to go about doing this is to try to get a common denominator. Because if I told you that something divided by 7 equals, I don't know, 13 divided by 7, I bet you'd tell me that that something must equal 13, right? That these two must be the same if the denominators are the same. So one way to do this problem would be to get a common denominator. So if I'm going to do that, right now 9 has a denominator of 1. So in order to get a denominator of 3, I'd have to multiply it by 3/3. And I now have an equivalent fraction. 9 is equivalent to 27/3. Is the same thing as 2x minus 1/3. Now that we have a common denominator, we can say, well, the numerators must be the same. We must be able to say that 2x minus 1 must equal 27. Solving that, we can add 1, you get 2x equals 28. And if we divide both sides by 2, x must equal 14. Okay, so that's one way to go about solving this problem. Another way to go about solving this problem. Okay, here we go. Another way to go about solving this problem is, and I think your teachers have taught you this because I've seen people do it, if we multiply both sides of our equation by 3/1, multiplying by 3 will undo dividing by 3. So these two operations are inverse operations. They cancel each other out. And what we're left with is 2x minus 1 equals 9 times 3 divided by 1, 27. And you'll notice we're in exactly the same spot. So we get exactly the same answer. X is 14. Whatever way floats your boat or makes sense to you. Let's see, number 6 is graphing some lines. Let's see if I can shrink this down a little bit. All right. So we had to graph a few lines. Looking at our line from part A, we had a y-intercept of 5. So on the y-axis, we can count up 1, 2, 3, 4, 5 units. We had a slope of negative 1/2. So negative 1/2 means we're going down half a unit every one time. Half a unit every one step over. Or you could go down 1 unit and then over 2. Down 1/2. Down 1/2. And sure enough, we've got ourselves a line. Okay. Pause and clean this up. All right, line B. So for line B, let's choose green for this guy. This one is already ready to graph. It's got a y-intercept of -4. So on the y-axis, you could go to -4, -1, -2, -3, -4. And it has a slope of 1. Well, 1 is a fraction. It's 1/1. So from this point, you could rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. And there we have it. Grab a line maker. I'm a little bit too... No, I better do it. I say I'm a little too lazy to do that, but if I don't grab a line maker, my lines just won't be straight. All right, so now I'm going to grab a green line maker and go right here. So sure enough, we have 2 lines graphed. third line. Get this third line. To graph this third line, we had to do some work. We could try to graph it without doing the work, but it's going to be a bit of a hassle. We could test some xy pairs that maybe we think work. So let's say I told you that x is 0. If x is 0, that means this whole thing is 0. What would y have to be to make this equation true? Whoops. What would y have to be to make 3 minus 3 times y equals 0? And if you're thinking 1, that's true. 1 should work. So 0, 1 is on this line. And then you could just keep testing values and see if you can find some other xy pairs that work. I don't know. I'll try another one. I'll try, say, if x is, let's try 6. If x is 6, let's try negative 6. Let's try positive 6. If x is positive 6, I'd get negative 12 over here. So 3 minus 3 times something has to get us negative 12. And you could try to solve this thing. I have a feeling the answer is going to be 5. 3 minus 15. 3 times 5. 3 minus 15 is negative 12. So 6, 5 is also on this graph. This is a real hassle trying to do all this work, though. It's easier. What you can do is take this equation, and put it in y equals form. So if I take this equation and put it in y equals mx plus b form, y equals slope x plus b, it will be much easier to graph. In order to do that, I would suggest starting by subtracting 3 from each side of the equal sign. Bring down a negative 3y equals negative 2x minus 3. And then we could divide through, divide each part separately by negative 3. Divide by negative 3 and divide by negative 3. And we get ourselves an answer. Y equals, negative 3 is canceled. Negative 2 divided by negative 3 is 2/3 x. And negative 3 divided by negative 3 is positive 1. Hey, look, we already knew the y-intercept was 0, 1. But we can now graph this line. Start at the y-intercept of positive 1, and my slope is rise 2, run 3. Rise 2, run 3. Rise 2, run 3. Grab a line maker, and connect some dots. All right, let's move on to our second to last question. Question 7 said, use an algebraic method to solve systems of equations. And then it gave us a hint. It said, notice that the equations in part A are the same as two equations in the preceding problem. So looking at these two equations, negative 1/2 x plus 5 and x minus 4. Oh my gosh, it's these two equations. So if you actually have any idea what solving a system of equations means, if you know what solving, here, let me find it here, what this means to solve a system of equations. What we're looking for when we solve a system of equations is we're looking for a point of intersection. We're looking for where two lines intersect or cross. So if you graph the lines correctly in the last problem, you already know the answer. The answer for where these two lines cross is, well, it's right here. The answer should be 1, 2, 3, 4, 5, 6, 2. It should be 6, 2. So we should be able to get this answer in part 7. Most people knew that to start this problem, to start solving this system of equations, you can substitute. You can say, all right, I know that y equals all this stuff, so I can take this stuff and substitute it in for y. So we'd have negative 1/2 x plus 5 equals x minus 4. And this is where a lot of people stopped or got confused because of a fraction. So if fractions bring you down, get really good at getting rid of them. And in order to undo 1/2, what we could do is multiply both sides of our equation by something that will cancel out 1/2. And that something would be 2. So if I now distribute this 2 times negative a half, 2 times a half is 1, so I'm going to call that negative 1. 2 times 5 is 10. 2 times 4 is 2, I'm sorry, rather 2 times x is 2x, and 2 times that negative 4 is negative 8. All right, well now we can solve this thing. I would start by, add 1x to each side. So I get 10 equals 3x minus 8. And then I'd add 8 to each side. Get 3x equals 10 plus 8 is 18. And if we divide both sides by 3, we get ourselves an answer. X must equal 6. So this shouldn't be a surprise because right here we knew the x value where they crossed was 6. We still need to solve for this y value, however. So knowing that x is 6, what we can do is use this 6 and substitute it into either one of these two equations. Either one. Erase this stuff so it looks a little bit better. And one of these equations sure looks a lot nicer than the other. This bottom equation looks very nice. So if x is 6, then y would have to equal 6 minus 4, which is 2. So y must equal 2. So y equals 2. If you're a real overachiever, you'll write your answer as a point, 6, comma 2. Let's take a look at the next one. Question B. So again, to solve a system of equations, you could again use the substitution method. Meaning, we could say if y is all this stuff, y is the same thing as 2x plus 10, then I can replace this y in the upper equation with 2x plus 10. So I would write a new equation, rewriting this equation up top. A new equation would be 3x plus 2, and now I'll replace this y with 2x plus 10 equals 13. And now it's just a straightforward equation to solve. I'll use the distributive property here. 2 times 2x is 4x. 2 times 10 is 20 plus 3x equals 13. 3x and 4x make 7x plus 20 equals 13. I can subtract 20 from each side. I get 7x must equal negative 7. And if I divide by 7 on each side of my equal sign, it turns out that x must equal negative 7 divided by positive 7 is negative 1. So hit hooray. But we're not done. We just found the x value where these two lines cross. We need to find the y value where they cross. And we'll go verify this with Desmos in just a second. So if x is negative 1, I can substitute negative 1 right in here for x. So I get y equals 2 times negative 1 plus 10. 2 times negative 1 is negative 2, plus 10 is 8. The y value where the two lines cross is 8. And again, if you're an overachiever, you'll write your answer as negative 1, 8. And let's go check on Desmos. In these two equations, 3x plus 2y equals 13. 3x plus 2y equals 13. So there's one line. And the other line is y equals 2x plus 10. Type that in. Y equals 2x plus 10. And sure enough, these two lines intersect at negative 1, 8. Pretty sure that's what we said, negative 1, 8. All right, last but not least, We're there, we made it to the last question. The last question, number 8, says, explain what your answer means. Whoops. Bring this up again. Explain what your answer in problem 7a above, right up here, means about the graphs of the two lines. And all I was looking for was to say, it shows where the two lines cross. It shows, whoops, it shows that the lines cross at 6, 2. Okay, that's what solving the system of equations means. It means finding out where two lines cross. I certainly hope this video is helpful for each and every person who takes the time to watch it, and thank you for taking the time. Bye now.